Replacing a turbo, we really need to know that the rest of the system is working properly. And one of those things we need to do is to test the lines that come from the back of the airplane to this pressure relief valve over here and to the pressure board. On the pressure board, there are three pressure transducers. This one here will measure the ambient pressure of the cabin. This one here with a red hose or a hose with a red marker is the one that shows the pressure going to the turbo. This hose connected to this port here is vented to the outside of the aircraft, so it monitors the outside air pressure as the airplane climbs. Now we want to be sure that these are properly connected, and all of these, this hose here must have a zip tie on it. This is a vacuum line, basically. It doesn't need a zip tie. Right? This board is either located on the front-facing panel that is at the aft bench seat for the single evaporator aircraft. In the 1000 aircraft with the dual evaporators, this would sit over here on the starboard side evaporator of the aircraft. What we need to do is to monitor this line here from the scoop side of the aircraft to make sure there's no leak in the line. And by the way, if we ever remove this line and we have the engines running with bleed air on, what will happen is that this pressure transducer will see no pressure at all, and it will then cause the turbo pressure to skyrocket, and it would destroy the turbocharger. So we must be sure that this line is never vented open when the aircraft engines are operating and the bleed air is on, because it would cause incredibly high turbo pressures. So we want to check this, the integrity of this line, and the other line we want to check, if you'll come over here, is to this pressure relief valve, which has a line that goes to the back of the aircraft, and it goes to the back of the pressure regulator. So in effect, if we open this line here, if we remove this line or open this relief valve, what would happen is that the turbocharger would be shut off because the pressure regulator will go to zero output pressure. This relief valve has some leakage in it, so in order to measure the integrity of this line, we're going to clamp this here so that we're checking only the line and we're not checking the integrity or the leak rate of this pressure relief valve. This valve becomes active as the airplane climbs to 21,000 feet. Under 21,000 feet, this pressure controller board, mounted either on the face of the bench seat or on the starboard evaporator, will control the pressure. Right? So we've clamped this line, and we're going to test the integrity of the circuit going to the turbo pressure transducer and the integrity of the line going to the mechanical relief valve that starts operating as the airplane climbs through 21,000 feet. This will show you an actual aircraft installation. This is an 840 that is completed, and we're going to show you where this pressure board is mounted. It's mounted right behind this panel here. That's in the aft bench seat. And to gain access to this, we remove these screws that pulls the panel out, and preferably to get to the mechanical relief valve that activates at 21,000 feet, we would have to remove the vertical portion of the aft seat first, then remove this bench seat and gain access to the pressure relief valve that's over here. If this were a 1000 style cabin with the dual evaporators, we would have an evaporator here on the starboard side with this board over here and a port side evaporator over here. Next, in our process of making sure everything is in order in the aircraft itself, what we do, we remove the rear scoop of the airplane. We've already taken out these mounting screws, and in order to remove the scoop itself, we take a 5/16 inch spin tight and remove the turbo pressure exhaust line, the vent, so to speak, from this side. They have a tendency to stick a little bit because that line gets rather hot. And this airplane has flown a lot. There we go. We have another line that's on the other side here. This is I believe that's a 7mm, which is the exhaust of the oil reservoir and the air mover, like so. Okay, now we need to remove these two hoses. The forward hose with a blue marker is the air inlet that captures the ram air from the front of the scoop. The rear one is the exhaust, so the air moves first to the heat exchanger with this hose and comes back on this side. So rather than removing the hose clamps here, we're going to loosen these two screws with a long Phillips screwdriver. We simply loosen these two Phillips screws. It's going to take about 12 turns on each one, like so. There we go. Now we pull this out and these disconnect, just like that, right? The only thing that's left now is the electrical connection to the scoop, and we don't want to stress that. I need this cutter, and when we cut these, we want to be sure that we don't cut the wire itself. And the safest cutter is it's not a side cutter, but one of these, and we're just going to cut that zip tie, and this is safety, that's not necessary, and we disconnect this here, and there's the scoop. This scoop needs a cleanup, and of course, if we were doing maintenance, we would lubricate this particular bearing and this bearing with a Teflon containing spray, like Tri-Flow is excellent, and we would lubricate this and this shaft here. This airplane has been in service for a long time, and normally this is a little bit excessive oil on here, but this is a high time installation, and we pay particular note to this line, which monitors the airspeed by the pressure, and there's a vent hole here that's directed about the axis of my finger here, and it connects to the circuit board and a pressure transducer here. Okay, now we go inside the airplane here, and I'm going to move these hoses aside, like so I have better access. And the hoses I'm interested in is, first of all, the line going to the mechanical pressure relief valve, which is right here. I'm going to cut this line here. I'm going to cut the zip tie. And again, if I were to remove this line, what would happen is that this pressure would not push the diaphragm forward, so basically there would be no turbo pressure reaching the turbocharger at all. The dome here is safety wired. The other line we want to access is the red line here that goes to the pressure transducer, the turbo pressure line, and the turbo pressure here comes from a copper line from the turbo inlet, goes to this manifold, and we're going to disconnect this hose right here. We cut the zip tie. They're stubborn sometimes. There we go. And we disconnect this line here. So now we're going to connect a manifold or a T to this line here, so we can apply pressure and check for leaks. And this brass T now connects to the turbo pressure line. It connects to a pressure gauge here, and it connects to a source of pressure right here. Now, coming from the brass tee, we have the one line that's going to go to a pressure gauge, and we want something like a 0 to 30 psi gauge. The other line I'm going to connect to a pressure source, a sharp air pressure, and I got to be careful that I don't apply excessive pressure to the aircraft. So I connected this, and if you'll notice, I'm showing 20 psi pressure here on this gauge. Okay, 20 is a good safe pressure, right? And we're going to use our hemostat here to shut off the source of air. And now, even with this disconnected, you see we're showing that air pressure. Now, if there was a leak, this would leak down. So I would leave this in place for about a minute and make sure there is no pressure drop. If there's no pressure drop, there's no leak. Next, I will move that manifold to the other line, and I'm going to do that right now. I'm going to reach in here, disconnect the manifold from the red line, and I'm going to connect the manifold to the line that went on the back of the pressure regulator that goes to the mechanical relief valve, and I'll again apply 20 psi pressure, like so, right? And I'm going to clamp this line, and if that gauge pressure doesn't drop, I don't have a leak. And that would happen rather rapidly. I would give it maybe, I don't know, a couple minutes, and that is all I need to do. What I've done is to make sure that the integrity of the sensing lines to the pressure controller and the relief line to the mechanical relief valve are intact. Again, if my red line had a leak in it, what could happen is that the pressure controller would think the turbo wasn't getting any pressure, and it would increase the turbo pressure to a point that the turbo would fail. Another consideration of a possible malfunction is this air mover. What it is, this connects to my turbo inlet pressure, and the turbo pressure going from about 4 psi at sea level with 0 cabin differential to about 25 psi at altitude, or about 20 psi at altitude. And that pressure causes this mechanism, this so-called air mover, to generate a suction. The suction is at this end and an outflow at that end. The suction side, the red side here, goes to my air outlet on the oil reservoir. This side goes to the scoop with another line. And what I want to do is to take this unit apart and make sure that, in fact, these surfaces are clean. If they are dirty, what happens? It no longer makes suction. If you don't have suction, the system will use excessive amount of oil. The suction creates a negative pressure in the bearing housing of the turbocharger. So in fact, the oil doesn't leak out of it, but air only comes into it. So I make sure these surfaces are clean. I will reattach this with the O-ring here. And when I screw it in, I'll screw it in all the way till it stops. Then I'll back it out. And if you look at this very carefully, I need to set this at a number 5. This is 1, 2, 5, 10. With this rod next to 5, I tighten the lock screw, and I make sure this is tight. So at one untwist, this side goes to the oil reservoir, that side is the outflow, and when I blow into this unit, there's air coming out of this, there's suction on the inlet side. To remove the turbocharger from the airplane, we first disconnect this hose here, and normally they have tape on them, silicone tape, and a hose clamp. Then we remove this oil line, and in a new turbocharger, we of course don't want to stress this fitting. There's an oil pressure switch here, which must be removed. or we can just disconnect the wires. Then we disconnect the the 1.5-inch hose going to the pressure regulator, and rather than unscrewing this, we remove these Allen socket screws. They take a 5/32 Allen wrench, remove this, and of course the turbocharger has a heat valve on it. There's a hose going to this, we pull that off. Then we remove 4 1032 screws, and the whole turbo comes out of the aircraft. To show you what it looks like in the airplane, let's go in the airplane to have a look. To start the cleaning and replacement procedure in the aircraft, we remove this oil system, and it takes 2 people, one from the back, one from the front, and there are at least 4 number 8 screws holding this oil system in the aircraft. So we remove that first, okay, and it's going to be flushed and thoroughly flushed and cleaned, and the filters replaced like we discussed before. Then we remove the hoses from the turbocharger and the inlet manifold here, the brass manifold, 4 number 10 screws down here, and we remove the entire turbocharger.